talking about T cell development, and then we're going to talk about positive selection and negative selection. So we know that T cells come from hematopoietic stem cells, which starts in the bone marrow. So these hematopoietic stem cells become hematopoietic precursors. And then after they become these precursors, they have these specific receptors in their gene that makes them migrate to the thymus. There's specific markers on them that they have. Even though they're not associated with T cells yet, they just have those specific markers that makes them travel to the thymus. So, once they leave the bone marrow, they travel through the blood, migrate to the thymic cortex. Now this is the early development of the T cell. So, right now when it enters the thymic cortex, it becomes the precursor T cell. And this is called a double negative T cell because it does not have CD4 or CD8 receptors on its surface. So we know that the CD4 is involved in T helper cells, and then CD8 cells are cytotoxic T cells, which interact with MHC class 1 and class 2 markers. So, but right now, they are neither. They are double negative. So this process is making them double positive. So we've got 4 different double negative stages. And basically, in a nutshell, this is just the gene rearrangement. Basically just making those CD4 and CD8 receptors. So first of all, we're going to have TCR locus rearrangement. It's just going to rearrange the locus. Then we move on to DN2, and at this point they are fully committed big T cells. DN3 to DN4, we've got that beta selection of proliferation. So basically what that means is that we're starting out with this one precursor T cell, and then through this process, the cells are going to multiply, and they're going to change specific parts of their genes. So at the end of this, you can have various T cells with various receptors on it, basically. So that's going to be that proliferation. And then that's from DN3 to DN4. And so when you get to the end of DN4, you're going to become a double positive T cell. And basically what that means is that, I don't think I drew that, but you're going to have, the T cell is going to have receptors for CD8 and CD4, double positive. And so, so from now, when we're talking about a T cell, it's either going to be, well, it can become a Treg cell, a natural killer cell. It can become any of these, but right now we're just going to talk about the cytotoxic and the T helper cells. So we know that it's going to have to specify what it's going to be. Right now it doesn't really know what it's going to be yet. So through the selection process, you're going to figure out if it's going to become a CD4 or a CD8, or it might not become either, and it might go through apoptosis. So after we've gone through this early development in the thymic cortex, we're moving on to the medulla of the thymus. And this is where we're going to have positive selection and negative selection. Positive selection is basically just an MHC restriction. So this T cell with CD4 and the CD8 is going to bind to MHC molecules. So if it has too high of an affinity, if it binds too strongly, that's bad, because we don't want our cells to overreact to certain MHC markers. So they're going to go through apoptosis. They're not going to make it. If they have no interaction at all to the MHC, that's not good. We need some interaction. We need, for antigens and self-antigens, we have to have some interaction. So it's going to go through apoptosis. But in the middle, we have low affinity. So it's right in the sweet spot. Not too high, not too much, just the perfect amount. So if it's got the perfect amount of reaction to an MHC marker, it's positively selected. So that means it's going to become either CD4 or CD8, because if it binds to the MHC1, it'll be CD8. If it binds to the MHC2, it'll be CD4. So once we have differentiated those, we've gone through positive selection. Now we go to negative selection. Now that we know that our T cells will bind, we need to make sure they're not going to overbind. They're not going to overreact. One more time, we've got to make sure. So then we're going to have this air molecule, and basically it's just going to present antigens. And so if the CD4 or the CD8 bind and overreact, it's going to go through apoptosis. But if it doesn't, it's going to become mature cytotoxic and T helper cells. And that's why it's called negative selection, because the ones that do bind die. They're negatively selected. But the ones that don't, or the ones that do bind, positively bind, are killed. But the negatively selected ones survive. And that is also called self-tolerance. So this is MHC restriction, self-tolerance, and this is going to get us to the final product, which is the mature CD4 plus, mature CD8 plus T cell. And so this is just talking about the CD4 and the CD8, but I mean this works for really any T cell. It can be a T-reg cell or a natural killer cell. You know, they're all going to have to go through this, but this is just focusing on MHC molecules.